Hey everyone, we're going to be working on the Titanic Dataset next. The Titanic Dataset, if you haven't downloaded it, it's located at kaggle.com. You can find it there and in the lab notes. Alright, so the file that I really want to work with right now is called train.csv. And train.csv is a comma-separated value file that has information about some of the passengers who were on the Titanic. We're going to eventually be using this data to construct a model that will help us predict who would survive and not survive on the Titanic. I guess I should back up just a little bit. If you hadn't heard, the Titanic was a boat that sank in the 1900s. There were very, very few survivors. About 38% of the boat survived. Yeah, so pretty famous story. There's, of course, a movie. Sorry if I just spoiled it for you. All right, so let's go ahead and get started. I've created a new notebook here, and I'm going to call this one Titanic EDA. What's an EDA? I'll tell you about that in just a second. All right. To get this CSV file into Python, there's a couple of different ways that we could approach that. There's a variety of CSV readers, but the one that I want to show you today is called Pandas, because Pandas is a lot more than just a CSV reader. Pandas is actually this thing that allows us to create what we call a data frame, and data frames are pretty awesome. Let me show you exactly what this looks like. So I'm going to start by needing to import pandas into my IPython session. So import pandas as PD. Once I do this, I'm going to be able to reference pandas as PD later on. And then I'm going to create a data frame, and I'll call it df. Not very creative. And I'll set that equal to pd.read_csv train.csv. Alright, so what this is going to do is it's going to read train.csv off of the disk and create a data frame. If you ever wonder how to work all of these functions and you have a question, you can easily click right over to the beginning of the bracket here and hit Shift-Tab, and you'll get all kinds of docstring that will tell you how to do it. You can expand it here. Lots of help. Alright, so I'm going to run that, and it runs almost instantly. And now let's look at the contents of df. Alright, so this is hopefully going to give you some insight on why I think data frames are so cool. This is something that R has had for a long time, and Pandas gives this functionality to Python as well. So what this is, a data frame, it's a collection of series. In each series can be a different type of variable. So for example, these could be numerical, this could be a string, and so on. So you could think of it as a two-dimensional array, but really I like to think of it as, more simply just a spreadsheet in memory. And Python data frames are very powerful, and I'm going to show you most of the rest of my analysis today is going to be based around how to do things in a pandas way, which might seem a little weird at first, but I think you'll get the hang of it pretty quick. If not, there's a significant amount of documentation on pandas as well. Google is your friend. Alright, so you can see that if I were to scroll down, I have 891 rows by 12 columns. So that means I have 12 variables and 891 observations. If I didn't see that at the end there, one thing that I could do that's pretty handy is I could do this, df.shape, and that'll tell me again the shape of the matrix is 891 by 12. Alright, just let's do a really, really quick back-of-the-napkin calculation here. I know that there were more than 891 people on the Titanic, so I wonder what proportion of these people survived versus what proportion of the people survived, total. What I'm saying is, how representative is this sample of the population? All right, so to do that, I'm going to do this. I'm going to talk about data frame again. And I want to call out one particular series this time, because I want to do an operation on the series called survived, which is my indicator, 0 for did not survive and 1 for did survive. All right, so ds.survived, dot value counts. This is one of the, I'm using tab to autocomplete there, by the way. This is one of the most powerful commands, I think, when you're doing a exploratory data analysis, or EDA. I'll talk about what that is in a second. And I'm gonna run that, and I'll see that what I have is I now know that 549 people in the survived column had a 0, they did not survive, and 342 had a 1, or they did survive. So if I were to do a real quick calculation, 342 divided by 891, I'm going to put 0.0 there to force that to be a float. Otherwise, it'll get cast as an int, and then we're going to get a 0. All right, so we can see that 38.3%, 38.4%, excuse me, of the sample survived. And so that does match pretty well with the population of survivors on the Titanic. So this is a pretty good representative sample. Okay, so let's talk for a second about, let's try this, EDAs. Whenever I get a new data set, the first thing I always do is an EDA. This is an important part of the life cycle. An EDA is called stands for Exploratory Data Analysis. It's a statistical term used by statisticians rather. And what we're going to do here is we're not actually looking for anything. We're not working to prove our hypothesis yet, or test our hypothesis rather. Instead, what we're doing is we're just learning about the data. We're exploring the data. For each variable, so the goal is to learn about the data. And so for each variable, things that I want to know include, is it categorical? Let's make a list. Why not? We'll use the power of Python. All right, is it categorical? Next one. What else should we know? If it's not categorical, if not, what are the min, max, and average values? Of course, if it is, what are the categories? All right. What are the categories? And then something else that I want to know about is, are there missing values? That's really important. In real life, the data is always a mess. For whatever reason, there are always going to be missing values. And so we're going to have to come up with some interesting and creative strategies for filling those missing values. In fact, I'm going to do an entire another talk about that after this one. All right, and then lastly, we don't have to get too into it, but I'd like to know something about the distribution of the variable. Distribution of the variable. All right, and so in my mind at least, that's an EDA. It can be a lot more involved than that. One other thing that we're going to talk about towards the end today is the idea of how variables relate to each other. That is, are they collinear? Do they move together? That is. There are other things that we may care to know. I'm only going to go into just a little bit of that now, and we'll drive more of that out as the course goes on. All right, so I'm going to start first, and I'm going to show you how I would do a EDA on, in particular, the category sex. So sex can be, it appears to be categorical, and can take on two variables, male and female. But let's say I didn't know that. Here is how I could do that EDA. Just as before, I'm going to go specifically, I'm going to reference the series sex, so df.sex, and I'm going to do value counts on it. All right. And I'm going to see that there are 577 males and 314 females in my population. All right. So we know that it's categorical. We can probably more or less at this point guess the distribution. I mean, we can imagine a bar chart like that in our minds, but just in case we couldn't, let's visualize it real quick. One other thing before we do this, if we're going to use visualizations, one thing that we need to do, this is just a little bit of housekeeping, is up where we start our notebook, we can do PyLab inline. If you don't do this, then what will happen is all your visualizations will get opened in a new window. You don't necessarily want that, so I'm just going to add that. And now all of our visualizations will be added in the same window. All right, so let's visualize. So if we were to do our same value counts command, and now we're going to say, please plot that. What kind of plot? Well, let's make it a bar chart. You can see that what Python will do is draw a nice bar chart for us right there. You can see male 577, female 314. All right. So let me show you a little bit about how we can slice in Python, in Pandas. This is pretty powerful. Let's say that we wanted to select the entire data frame. We could just do df. Well, let's say if we wanted the data frame, but only the members of the data frame who were female. Well, the way to do that would be to create a slice. df.sex is equal to, remember double equals because we're not setting something, we're comparing female. All right, if we do that, what we'll get is a data frame back. This is actually a new data frame that we're outputting, and you can see that it's all the females that were on the boat. In our sample, that is. All right. One other thing that we would want to do with sex is we would want to make sure that there are no missing values. And the way we can do that is I'll slice the data frame, and I'm going to slice it by selecting df.sex is null. So up here, if you remember, we said df.sex is female. Here we're using a special function built in that's saying show us the ones which are null. And you see that there are none, and that's good because that means that all of the passengers have a gender assigned to them, either male or female. All right, so that's how I would do a simple EDA on one variable. Let's repeat the process again, but instead let's use fair. So in this case, I'm going to look at fair. And as you can imagine, this is probably going to be the amount paid per a ticket, the cost of the ticket. So df fair value counts now. Oh, yeah, see, this is different. So what we have is lots of different numbers here. In fact, you see there's so many of them. There was 248, so Python cut them all off, so I don't have to look at them all. It says, here's the summary dummy, but you should probably do this some other way. All right, so this is definitely a continuous variable, as opposed to categorical. If we didn't know this, something else that we could have used, and I kind of should have told you about this before, but I was holding this back, is df.describe. So check this out. What this will do is for any continuous variable, it will give us the mean, standard deviation, minimum, and then the percentiles and the max value. So we can see that there were 891 counts of fare. The average fare price is 32 with a standard deviation of 49. So that's quite a large variety of fares. The minimum fare price is 0, and that's interesting. The maximum fare price was $512, and that's a lot of money for, I believe the Titanic sank in 1918. I should know that. Anyway, so that gives us some insight into the into fare. One other thing that we want to do is sort of understand the distribution of fares, so we know that this is the average, but really, what does it look like? And so we can do that with using histogram function. We'll use let's not do that yet. We'll do this. We can see that we have a histogram, and you can see like probably one person paid $500 for their ticket. Most people paid, you know, 0 to, I don't know, is that $50? Yeah, that looks about right. And if we want to make this just a little more readable, we can do bins equals 5, or, you know, whatever number you'd like. And here we can see this makes a lot more sense. Yeah, it's a little bit more compressed anyway. All right. One last thing. Before I call my EDA of fare done, I'm going to check and see if df.fare is null. Yep, there are no null fares, so that's really good. Oh, boy, you know, one other thing I'm interested about. Remember that thing where we said some people paid 0? I'm curious about that. And curiosity sometimes leads to discovering some interesting things. So let's look that up. Let's look for df, where df.fare is equal to 0, not negative 0. All right. Here are a bunch of the people that paid 0. There's actually quite a few of them. All right, so what I'm going to do is I'm going to grab this one just out of curiosity, and I'll search for him in Google. Here he was. So this is Mr. John Kerr Jordan George. Yeah, I'm not going to try to say his last name. My apologies. He boarded the Titanic at Cherbourg as a first-class passenger, carrying the ticket number 19972. The ticket was complimentary because of his position with the Holland American Knot Line, which was part of the International Mercantile Marine. So, Mr. John Kerr was lucky enough to win a free trip on a sinking boat, and that explains why he actually paid $0. That's pretty interesting, maybe not useful. And it certainly didn't work out for Mr. John Kerr because he did not survive. All right, one other thing that I'm going to show you. Let's say I was doing a EDA of cabin. I can select, this is how I would see if there are null values in the cabin variable. We can see that there most certainly are. Here are all of the null values in the cabin variable. And the reason I'm doing this is just so you could see what one looks like if there are missing values, because we have not actually experienced that yet. All right, in my next, one more thing I want to show you. I almost skipped my notes. There's one other thing that we tend to like to see in EDAs, and that's we just want to start understanding the relationships between variables. In particularly, I want to know, are there things that absolutely perfectly move with my dependent variable? And then the other thing that I sometimes care about are, is there two or more values that are multicollinear? That is, when one increases, the other one increases in perfect unison, or almost perfect unison. That can be a problem for us. Later on, we're going to talk about multicollinearity and why it's a problem. But I'm going to show you just a little bit about how I would look for that. So one way that I'm going to look for that, this is a little bit more of a fun example. You've probably heard the phrase from you know, early sea travel, and that's the idea that women and children should be first when abandoning a ship. So let's see if that's really true. We should be able to tell that pretty quick. I'm going to just put a little comment in my code there so I understand what we're going to see. So, let's see. I'm going to slice my data frame for df, where df.sex is equal to male. Oh, that's not quite right. There we go. So that's going to be the male data frame. I'm going to look at survived out of that data frame. So I'm going to look at the survived series for only males. I'm going to do value counts on it. And then I'll plot that. Oops. You know here the bar H, that means I'm using a horizontal bar chart. Uh-oh, that didn't quite right. Aha. Spelling is always going to get me. S-U-R-V-I-V-E-D. And there we are. So you can see that the number of men that survived, 1, is about 100, a little bit more. The number of men that did not survive is much higher. Okay, so let's look at the same thing except for female. If women and children were really first, then we would expect there to be more female survivors than males. So we can quickly look at that. All right, so you can see here the number of female survivors, 1, is quite a bit higher. These basically have switched positions. The number of females that did not survive is much lower. You also notice something interesting here, and that's that I only have 1 bar plot, even though I've actually asked for 2 up here. That's because the second one overwrites the first one. I can quickly deal with that, though. What I can do is I can use subplots. And you probably don't need to know this, but I'll show you just in case you're curious. If you didn't know this and you ran into this problem, what you could do is you could just take one of these plots and put it in another cell. But yeah, I'll show you how to get around that. Essentially what I'm saying here is I'm asking Python to draw both of these charts, but in... oops, that's not quite right. I can't type and talk at the same time. But draw them as subplots of one larger plot. All right. Let me see what I did wrong. Oh, yes, comma. There you go. And so we can see... Well, we can see something, and we can infer that this is male and this is female, but let's make it better one more time. Otherwise, this is very easy to misinterpret, which is not what we want. All right. Here we go. And so you can see the males that survived, 1 is very small. The females that survived, 1 is very large. So that's good. That does confirm our thought that women, well, at least women, were allowed to be on the life rafts first. At least this would suggest that. Right. So children, that's a little bit harder. What I'm going to do for that is I'm just going to use a different frame, and I'll say df.age now is less than 15. Let's call under 15 a child. That's a total wild guess on my part. Again, this is more about back-of-the-napkin calculations. We would want to more accurately define a child if we were going to actually try to prove this at some point. All right, so we're going to do about the same thing, but here what I'm doing is I'm asking for the survived value counts of people who were under the age of 15. All right, and you can see that, well, yeah, more survived than not, but it wasn't really a good situation either way. Yeah. Okay. Now, this does lead you to a question, though, about, well, what about male children versus female children? Well, I don't know. So let's find out. We can do that. We're going to need a little bit more complex of a slice. And here's what I'm going to do. I'm going to say df, where df less than 15, and I'm going to throw in a logical and there. df.sex is equal to female. And we'll run that one. Oh, good, that worked. I'm going to copy that, and I'll paste it one more time, and except I'm going to change it to male here. And again, I could do subplots, but this is faster. All right. And so this gives us a little bit more understanding of how the genders break down. If you were a child, it looks like you're probably better off if you were a female child than if you were a male child. This isn't surprising. We knew this going into it, but my point wasn't really to discover something new about the Titanic here, but rather use an interesting example from history to show you how to do complex slicing and EDAs. All right, I hope you found this interesting, and I hope you learned something. In the next video, I'll talk about how to handle missing values. Thanks for listening.